Hello, good people. Welcome to my channel, St. King Academy. Today, I want to look at transformation, and we want to look at translation. Okay, so translation. These are congruent shapes. They are congruent shapes. So the question reads: Triangle ABC was mapped onto triangle A2B2C2. Describe completely the single transformation. So if our triangle ABC was mapped onto triangle A2B2C2. So the question is saying describe completely the single transformation. So the first stage is to join our corresponding points A and A2. So we are joining A and A2, then B and also B what? B2. So we are joining our corresponding points, then C and C what? And C2. Okay? So we have joined our corresponding points. Okay. So if we join our corresponding points, as you can see, we are getting parallel lines, right? So they should be equal in length. So let's try to measure. It's 13.5, then another 13.5, then B and B2 13.5. So we joined our corresponding points and we get parallel lines which are equal in length. That means that is translation. So we're going to answer. So translation. Then you want to get the what? The translation vector. TV is equals to ending point minus starting point. So triangle ABC was mapped onto triangle A2B2C2. So we want to find the translation vector. So ABC right here, that is our image. So our pre-image, that's the original shape, our pre-image. And this one right here, A2B2C2, is our image, which is our second shape. Okay, so that is our ending point right here. So we can take A points of A2 it's 4 and what? 4 and 2. That's our ending point. 4 and 2 minus starting point. So we're taking corresponding points A2 minus A, the starting point. So it's minus 3 and 3. Minus 3 and 3. So I'm going to take minus 3 and 3. Okay. So 4 minus 3, you get what? 7. 4 negative, that's positive. So 2 minus 3, you get minus what? Minus 1. That's our translation vector. Okay, let's say you take B2 and what? And B. So I want to take B2 minus B. B2, that's 4 and what? And 0. 4, 0 minus B, that's minus 3 and what? And 1. Okay, that's minus 3 and 1. Okay, so 4 minus 3, what do we get? We get 7. 0 minus 1, we get minus 1. Okay, so what am I trying to explain here? If you take any point, either C2 minus C or A2 minus A or B2 minus B, we still get the same translation vector. So translation, it is the movement of shapes, lines, and points without changing what? Without changing direction. Okay, let's say another question, say triangle A2, B2, C2 was mapped onto triangle A1, B1, C1. Let's say in triangle A2, B2, C2 was mapped onto triangle A1, B1, C1. On this case, triangle A2, B2, C2 is our pre-image. So A2, B2, C2 was translated onto triangle A1, B1, C1. So the first stage, we joined our corresponding points. We join our corresponding points A and what? And A1, B2, and what? And B1, then C2, and what? And C1. Okay, so as you can see, we are getting parallel lines, and they are equal in length from this point to this point, this point to this point, this point to this point. They are parallel and they are equal in length, and our shapes are congruent. So if we join corresponding points and we get parallel lines which are equal in length, it means it is translation. Then we are answering now the question, translation. Then what's next? Translation vector is equals to ending point minus starting point. So ABC was mapped onto A1, B1, C1. A2, B2, C2 was mapped onto triangle A1, B1, C1, which means this triangle right here, A1, B1, C1, is our ending point. So we are taking what? Our coordinates. On this case, let me take B1 minus B2. B1 is what? 1 and negative 3. So 1 and negative 3 minus B2. Oh, that's 4 and what? And 0. 4 and 0. So 1 minus 4, what do you get? You get negative 3. Negative 3, negative 0. Minus 3 minus 0, you get minus what? Minus 3. That will be our translation vector. And if someone check C1 minus C2 or A1 minus A2, we will still get the same translation vector. So that's for translation. Thank you for watching, and please let's subscribe.